All right. Hello, everybody. So this is Sir Gabs, and our lesson for today would be object-oriented programming in Java. So these lessons will cover the concept of OOP, the four pillars of OOP, and of course, example code or sample code implementing those concepts so that you can truly understand the concept of OOP. All right. So let's start. Let us define OOP first. OOP stands for Object-Oriented Programming. It is a paradigm in programming that is based on the concept of objects. So, in this kind of programming, you must treat anything or most of the thing in your program as an object. So, what is an object? Objects can contain attributes or fields and procedures or what we call the methods. Okay. So you can treat an object as a real life object, for example, a car, a dog, or you can treat an object as an abstract object, of course, related to your program, for example, a database connection. An object can be represented by a class, but the class is not the object itself. The object will become an object when you create an instance of a class. So keep that in mind, okay? So again, we can represent an object before being instantiated as a class. I'm going to use car as an example. This car, we can treat this car as an object. But again, we can truly say that it is an object if it is an instance of a class. So we can say that this is a class. Okay? So a class car has a fields and has a methods. So a fields are the attributes or data that describes the class. So for in this example, the color, the model, the maker, and the fuel type describes this class car. At the same time, the method are the actions that the class can perform. So for example, a car can start engine, can accelerate, and can stop. Right? So again, this is a class of a car, and this is an object. But if we want to make this a real object, of course, we need to instantiate it to another car or to an instance of a car. Okay, as I said earlier, a class is a blueprint and an object is the instance of that blueprint. So let us say I create a new car, and this new car has a color red, has a model Toyota. Maker, let's say 2020, and the fuel type is diesel. And then, of course, this car can start its engine, can accelerate, and can stop. Of course, I can create another instance of this class car. Okay, so another object, another word. So let us say car 2 has a color of green, a model of Mazda, make year, let's say 1990, for example. Then fuel type is gas. Of course, it can start its engine, accelerate, and stop. So that is the basic concept of the object. So again, an object is represented by a class with fields and methods and can be instantiated into another specific objects. But remember, a class is a blueprint for objects. Okay? So let's give another example. So this is an oversimplified version of a class person. So we have the fields for name, age, and gender. We have the person has a methods, say name, eat, study. Again, this is an oversimplification of this class person. So we gave car and person as an example. Those two are real life objects. So how about abstract objects in programming? So most of the time we're dealing more on abstract object than real life objects. So for example, database connection. So database connection can have fields which has a server, username, and password. So server is where the database were hosted. Username and password is the credential for those for that a database. So if you have an idea on how to connect, for example, an SQL server, so the connection string will ask you for a server, for a username, and for the password. Of course, the database connection has its own method. The database connection can be connected or can be disconnected. So this is an example of a class for database connection. So let us give an example. code on how are we going to create or use or so for us to understand what is a class and an object is. I have here a Java program, the basic Java program. I created project already in NetBeans. Of course, you can use your own ID if you want. So by default, we have the main Java file. So to create a class, you just need to indicate class and then the class name. The class name should start with a capital letter. That's a requirement. And then if you're going to save that class as a file, you must name the file exactly what your class name is. So for example, our class here is main, and then our file name is main.java. And then under this class, of course, you can have your method and you can have your fields or attributes. All right. So in here, we have the main class. Of course, this is the default class that being created when you create a Java file or Java package. And then we have the main method, which is the method that being run when you run the program. This is the first method that being ran when you run the program. Let's create our new class. So for us to be able to create a new class, let us click this new file. Then I'll select class. I'm inside the project Java OOP review. Okay. And then I'll name this class. Let us say I'm going to make a class for a student. Okay. It's not it's an object, student object, not a class as classroom. Okay. So let's click finish. And as you can see, Java generates these codes already for us. So I'm going to remove this extra code so that you will not get confused. Okay, so let's study this code first. So this student class is defined as class with capital letter S, of course, and saved or stored to the student.java file. Okay, if you could see, they have the same name. Okay, and it's under the package Java OOP review. A class could have an attributes and method. So an attribute again describes the class. So for example, I'm going to give a few attributes for a student. So let us say let's have integer ID, student ID of course. So string name, and then we can give let us say int age. Of course, you can give a lot more attributes so that you can describe your class properly. I'm just oversimplifying our code. Of course, a class could have a method. So a method or the action that a class could perform when it's being instantiated. So for example, I have here public void say name. This class could say its name. So hi, my name is, and then we can indicate the name of this class. So the name of this class is this name method. So to indicate the attribute of the same class, we just use to need. We're going to need to use the this followed by the attribute of that class. So where this is indicating that we are talking about this class, and this class that followed by a name, which is this class or this student's name. Okay. So we can also give another method. Let us say name, say age, and then let's change this to age. Let's change this to ID. Okay, this is an example of a class. So as I have said earlier, a class can be instantiated. So let's instantiate this student class. So let's go back to our main. Of course, our main file can see this student file because they are belong on the same package, if you could remember. So to instantiate this class, I'll just use this code. Student, I'll name the instance of this student as student1 is equals to a new student. So when you type this code, when you see the new student, you created an instance of a student class, and that instance is student1. Of course, you can create multiple instances of student. So let us say I create another student 2 is equals to new student. And this students, student 1 and students 2 is what we call the object. It has the characteristic of this class student. So we can assume that student one, okay, has an attribute ID, name, and age, and has a method of say name, say age, and say hi. So if you're going to try that, let us say student one, then if I indicated a dot here to access the our class, we can see the attribute age, ID, and name, and we can see the method say age, say ID, and say name. So if I said say name, and then we run this code, it says that, hi, my name is null. Why it was null? Because we haven't indicated a value for this, for our, for that class fields. Okay. So to indicate the value of a field, let us say student one dot name is equals to look. What I'm showing you here is not the common standard of giving the fields a value. I'm just going to show this to set an example so that our say name could have a value. But this is not the right way you're going to do or to give a value to your fields. Okay. So if we run this, hi, my name is Ziluk. Okay, because we give the student one an object or an instant of a class student a name. We give it a value Ziluk. Of course, student 2 is a different object than student 1. Their their object origin is the student, which is the same, but they are different object because they are different instance. For example, I'm going to give this Mona. When we ran this, we have two value here. So Diluk and Mona. Of course, they came from one originating class, which is the student. Okay, they are being instantiated from the class student. So we can assume that they are what we call the objects. Okay, so that's the basic of uh, class and object in OOP. Now let's go back to our slide. So let's discuss the four pillars of OOP. So this is the four important pillars. So we have the abstraction, the inheritance, the polymorphism, and the encapsulation. So let's start with the abstraction. So when you say abstraction, okay, it is one of the concepts of OOP that show us simple things that represents complexity. For example, what are the simple things that represents complexity? You have a remote control, of course. So the thing is, you are using a remote control, but you really don't need to know how a button works in technical terms. Of course, if you're talking about remote control, when you press a button, it will trigger an electric something like that to make the chip of that remote to work like this to send the signal to the television. Okay, so what I'm trying to say is, if you are using a remote control and you know that this button can turn on the television, it is not required for you to know how that button works. So that's an example of abstraction. You don't need to know the details. You are being presented with a simple interface, simple buttons, simple object, for example, and you don't need to know the details. So that's the concept of abstraction. An example of that would, of course, are the objects, classes, and fields and methods. To make you understand what abstraction is, let us forget for a while our class here. Let us focus on one of the most commonly used code in Java, which is the system.out. I know that you always use this piece of code to print out a string to your console, right? So for example, if we run this code, you could see here, hello. The question is, do you need to know how this hello string be printed on your console before you need to use this simple piece of code? Of course, the answer is no. We are presented with this simple code, and we know that this code do something, and we're just going to use it. So where is the abstraction in here? So the abstraction in here is that we don't need to know the codes behind the print line method. What is important for us is this simple piece of code. Okay, if you throw in a string on it, it will display it on the console. You don't need to know what does the print line method do. Of course, the print line method is under the instance out, a static instance out from a final class called system. Now imagine if you need to study the details of what behind this code is before using print. Well, I guess that Java language would be one of the hardest language compared to other languages. It's just simply that abstraction, okay, abstract the complexity and presented you with a simple things like this. So that is also the same with our created class in here. So we have here say name. We don't actually need to know. Of course, it's not always. Okay, sometimes we need to know, but most of the time we don't need to know what does this method do or how does this method do its things. We all know that if we use say name, it will print out the name of this object. Of course, you can observe what does it do, but in simple point of view, you really don't need to know unless you're going to override it, overload it. That's the concept of abstraction. Now let's go back to our presentation for our next concept. We have the encapsulation. Okay. So what does encapsulation mean? Encapsulation provides protection or privacy for a class, specifically its field. Okay. It's like a protective barrier that keeps the data and code safe within the class itself. So to do that, we use access modifier and a getter and a setter. Okay, so let's have an example. So privacy is important to a class. Actually, you must set your fields, your class fields, private by default, according to the common convention in programming Java. So what does privacy do? If you look here in our class, let's focus on fields. In here, we have the integer ID, name, and age. I did not indicate any access modifier in here. So what are access modifier? So access modifier is what we call, is like this. This is access modifier, public. And then we can also give access modifier as private. And then we can also indicate access modifier as a protected. And then if, of course, we did not indicate any access modifier, it's called a default access modifier, which is a package access modifier. So I'm going to discuss what this access modifier is first. So if we gave a class or an attribute, for example, in our case, a public access modifier, you're allowing these fields to be accessed anywhere within your application. Okay, so there's no restriction at all. On the other hand, if you gave an attribute a private access modifier, you are restricting the access for these fields or method if you want, okay, or class. You're giving the access of this field restricted just within its own class where it was declared. For example, I can only access this name attribute within the student class. I won't be able to access the name attribute. If you could see here, it results an error, okay? Because this is a different class. Even that you inherit it, I will show you an example later. Even that you inherit this class, you won't still be able to access this name. A private access modifier gives you a total protection for your attributes or method or anything that you're going to put this access modifier. On the other hand, protected is somewhat similar to private, but instead of granting access only to this class, protected allows you also to grant access to this attribute from another class as long as you will inherit this class. Of course, again, I will discuss inheritance later. So you use protected and you want to use this attribute from another class, make sure that that class inherits a student class. Okay, so let's make this class let's encapsulate the attributes of this class. To do that, of course, we need to set its attribute to private. Now, since this is private, this main method won't be able to access these attributes, okay, because it was set private. So for us to be able to access that, we need to use what we call the getter and the setter. A setter is a method that will set a private field. And a getter is a method that will return the value of a private field. So it's up to you if you want to give a method private, a getter and a setter. But in our case, for us to be able to access these encapsulated fields, we need a getter and a setter. So what we're going to do is to public void set ID. And then, of course, since we're going to set ID from outside, we're going to ask for integer ID. And then let us set the value of this ID. So this ID, if you can see, you can access the ID even if it's private because we are on the same class where the private field was declared. So this ID is equals to ID. Now this code means that we're just giving a value to this ID right here. Okay. And then of course to produce a public, to produce a getter, okay, we have a public int as a return type, get, and then we're not required to throw in any parameter, but we're required to return the value of this ID. This is an example of a getter and a setter. Okay, you go back here. We haven't indicated a getter setter for the name and age, so I'm going to do this to highlight this, and then right click, refactor, and then let's select encapsulate fields. Then if you can see here, generate getter and setter. So get name, get age, set age, and I'll click refactor. I'm just going to copy this one, so I'm going to make our code more readable. So I'll put it right here. All right. So we have now a getter and a setter for ID. We have now a getter, a setter for a name. And then we have now getter and setter for age. So if we go here, for us to be able to set the value for the attribute name for our student one, of course, you could remember that. We need to use the getter and the setter. So we type in student one dot set name. And then our name, sign name would be zlook. That is also the same with for our second object here. Okay. So student two that set name zlook. Sorry, should be Mona. We now have be able to set the value for our private methods. Okay, so that is the concept of encapsulation. Of course, we can get the value of that from our getter. So let us say SOut name. Let us say name, then plus. So to get the name of zlook without using the say name method, so I'm going to use student one dot get name. This method call will return as a string of the name. Okay, so in here, name zlook. Okay, so that is what we call encapsulation. Okay, now let's proceed to the next concept, inheritance. So inheritance allows a class to inherit the fields and methods of another class. This is where the concept of parent and children class will occur, or the superclass and subclass. So for example, in our example, we have a class student. Now let us say I want to create a class that will inherit the attributes and method of this student. So let us say I'm going to create a new class within our Java OOP review project. And then we're going to create a new type of student, which is what we called a scholar. So of course, a scholar is a type of student. So instead of creating a scholar class and copying the code, all of the code from our student, instead, we're going to inherit all of the attributes and method of the student class to our scholar class. So to do that, we need to use the keyword extends. So public class scholar extends, and we're going to extend student. Now, you will look carefully. We're not going to add anything inside this scholar class. Okay, not going to add anything. But if we use that scholar class to create a new instance of a student, we can actually do that. So instead of creating a student, we were going to create a student scholar. So scholar, student, tree is equals to new scholar. So this student tree is an instance of a class scholar which inherits also the attributes and the method of the class student. So therefore we can assume that a scholar is a student. Okay? Okay. So if that's so, we should be able to use all of the methods and attributes of this class to this class without indicating all of those or without copying all of those code. So let us say student tree, which is an instance of scholar. Okay, we can set its name, set name, and then we're going to give this. Let's say this is Venti. Of course, we can also print, or we can ask the student tree, which is a scholar, say name. Okay. So if we run this, we could see that we able to set Venti as the name for this scholar class, and we able to use the same name method for this scholar class, even that we don't have the code in here. Okay, so what we did here is we extend the class student. Therefore, we can assume that this scholar is also a student. It also has the, the attributes given to this class, student class, and the method given to this student class. So that is inheritance. Of course, we can create another form of students if you want to. Okay, but this is the example of inheritance. Aside from that, since scholar is a different form of student, we can give its own field and its own method. So for example, I will give this scholar a new field. Let us say int allowance, private int allowance, and then of course we can encapsulate this field. So we can generate setter and getter for it. Now, if you go back here, we could set the student tree allowance student tree that set allowance, right? Set, let us say 1,000. Okay, and then we can print out, okay, s out, print out student tree, and print out the student tree's allowance. Okay, so we run this, we able to set allowance for 1,000 value, and then print out the allowance. Okay, now let us make things clear. Okay, a student is not a scholar, but a scholar is a student. Okay, so let's prove that. Okay, so we already proved that a scholar is a student because we able to access the attributes and method of the student class. But if you're going to access the methods exclusively to scholar from a student object, you won't be able to do that because, as I've said, student is not a scholar. Student may become or can become a scholar, but it is not a scholar. On the other hand, scholar is always a student because we extended student here. We inherit students cluster. So to prove that, we use student one. As we all know, student one is a student class. Okay, and we are going to access set allowance. Okay. If you can see here, there's no method such as set allowance. Why? Why there's no method set allowance? Because if you could look in this student class, there's no set allowance method. Okay? So that proves that the parent class can become a scholar class, but not, parent class can become a child class, but it's not the child class. On the other hand, scholars can be considered as, child class can be considered as the parent class. Okay, so that should be clear. So that is an example of inheritance. Okay, of course you can inherit a class that has inherited something from the other class. But as far as I know, you cannot inherit multiple class in one class. Keep that in mind. Now let's proceed. Polymorphism from the word poly means many, and morph means form. Polymorphism is a concept in OP that allows you to make a method with many forms. To do that, we have what we call the method overloading and method overriding. So method overloading allows a single method to have many forms in terms of its parameter or return type. On the other hand, method overriding allows a single method to have a different form in terms of its functionality. Let us give an example. We're going to use uh, method overloading first. Okay. It says that method overloading allows you to have a single method, multiple forms, as long as you will change its parameters. Okay. So, for example, we're going to use say name. Okay. We're going to use say name as an example to overload. Okay. To make method overloading works. Okay. So it says that a single method can have multiple forms. So what we did is we copied this method and paste it here. So we now have two method from a single method. But if you could see here, we result to an error. Why? Because you're only you will only be able to make a multiple instance or sorry, multiple forms of a method if you overload it. So how to overload it? Okay, to overload it, you must change its parameter. So in our first method, say name, we don't indicate parameter. In here, we can indicate a parameter. So let us say I'm going to ask for a string language. Okay. So what are we going to do is, if we call say name without indicating a language parameter, the output would be, hi, my name is. On the other hand, if we call say name, and we indicated a value language, we are going to do a different thing. So for example, if language that equals to Japanese, say hello or say my name in Japanese. Else, say my name in English. Also in here. So dito. So here, I'm going to write instead of hi, on konnichiwa. So let us say konnichiwa. Okay. And then instead of writing my name is, we're going to write watashi no mae wa, followed by the name, and then followed by, okay. So in here, in our example, we have two same method, same name, but different functionalities based on their code and also different parameters. So if you go back here, then we say on the upper part as student one, let's say name, this method call, we call this method here. If you want to call this method here instead, okay, so what we're going to do is student one that say name, and then we're going to indicate a string, let's say Japanese. Okay, so what we're going to see in the output should be, hi, my name is Dilok, and here is konnichiwa, then Nihongo, then Dilok desu. Okay, so let's try to run this. So in here, oh, yes, wait, let me check the code first. Okay, should be saying. Okay, then let's run it. Okay, so in here, we see this first method call works as expected. We don't throw in any parameters, and it print out my name is Dilok in English. And then in the second call of the same method, we indicated a parameter Japanese. Then instead of printing English, it print out konnichiwa watashi wa namae wa Dilok desu. So it prints it out Japanese. Same method, but many forms. So that is an example of method overloading. Okay. Of course, we can also overload what we call the constructor. So what is a constructor? If you could see here, we did not indicate any constructor. Okay. So again, constructor is a method that will be invoked once you created an instance of a class. So we created an instance here. Okay. So if you did not indicate any constructor in here, it will use the default constructor of your class. So the default constructor of your class look like this. So public student. So this is the default constructor of your class. Okay. So what does it means that when you create a new instance of student, which is by the keyword new student, okay, you're going to call this first. Okay. Now, the common constructor in a class asks the creator for parameters to fill in these attributes of that class being instantiated. So we can actually overload a constructor like this. So again, overloading is copying the code and then changing its parameter. So in here, I could say int id, int age, and then based on what the caller of this or the creator of the instance of this from the parameter, we need to set the attributes of this class. So this the id is equals to id. So this the name is equals to name, and then this the age is equals to age. Right. So this is an example of constructor. Again, this is a constructor overloading because we created a multiple instance of constructor. So if you want to create another constructor, overload another constructor, as long as the parameter is different, that's allowed. So in our example in here, we're going to create a fourth student. Student is student 4 equals to new student. But this time, we're going to indicate parameters in here. So first, we need to indicate the ID. So this is the student 4. So you can say this is 04. Then we indicate the name. Okay, so let us say Clay. And then we indicate the age. Let us say 25. And then we don't need student for when we're going to use or to access the attributes of student for, we don't really need to set its name or its attributes one by one because we already set it here automatically. Okay, so to prove that, let us say student 4. So if we run this, so in here, student 4 says, hi, my name is Click. We did not indicate the set name in here because we already indicated or the value of the parameters, or sorry, the value of the fields of the student from this parameter and from using this constructor. Okay, so that's the example of overloading. Now what we mean by overriding. So method overriding. Method overriding is using the same method but changing its functionalities. Okay, so let's go for on the scholar. So if we all know, scholar inherited student, right? Okay. And student has a method say age, and of course it was implemented automatically here on the scholar class because we extended student. Now what we want to do is to use say age, but instead of printing out, I haven't changed it. Pala. So my name is age. Okay. So instead of saying my age is, instead I want to I want to output a different string instead of saying my age is. So what I'm going to do is to indicate or declare say age method in here. Okay, this say age method is the same in here. Okay, that's why when we declare it here in the scholar class, okay, there's a warning. It says that you need to override you need to override this method for you to be able to redeclare it. So what I'm going to do is to add a overriding notation. So just click enter, then enter. Then in here we have at override. It means that we're indicating that this method below here will be overridden. So what we're going to do is instead of printing, hi, my age is, I'm going to do this. Hi, my age is, and include. Okay. So we've changed the content of this say age just in here, in this method. We override the true value or the true code of this method in here. Okay? So what happens is say age has now two instances or two forms. Okay? The say age in this scholar class and the say age in this student class. So for example, let's say student 4 dot say age. Okay. So we're going to use the original say age in here. So if we run this first, so my age is 25. Now if we created a new student, let us say student 5, 5, and then student 5, say name, student 5, say age. Okay. So what we're going to expect here is that the output would not be hi, my age is 26, but rather hi, my age is 26 and I am a scholar because this method say age, the one that we're calling, is okay. From the, I have something to change first. Instead of student, this would be scholar. Okay, scholar. All right. Okay, so what we're trying to do is to create a scholar method. Okay, but I forgot to add, to indicate, we forgot to overload the constructor of our scholar method in here. So let's do that quick. Right. So instead of student, we're going to make this scholar. And this is also a scholar. The thing is, you can set it's allowed in allow. So if you could see here, this line of code is resulting to error. So we're trying to access ID. As we mentioned earlier, ID is unprivate. That's why it was encapsulated. So that's why we won't be able to access the ID. So for us to be able to access it, we need to use this code instead. Example, we're going to use super that set ID. Okay. So what's this line of code do? So super indicates the parent class. So the parent class of our scholar class is student, which is this class. Then we need to access the ID or the set ID method of that parent class. So we're going to access this. And then we will going to throw in the ID parameter in here. Okay. And then it's going in this variable, then going to this, fields. And then we will now be able to set, okay, the value of this ID field. So that's one way to do it. Okay. But instead, what I'm going to do is instead of setting its ID like that, I want to set directly the ID of our ID attribute back there. Okay, so we're going to derail a little bit on our polymorphism topic. We're going to go back to encapsulation again. Okay, okay, let's go back. So to do that, so for this scholar class to have an access to this student class, we're going to set this attribute instead of private to protected. 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 So when I set this protected, the class who extends this class will now have an access to my protected field. So in here, so we have the super.id. Then we can equals ID. Okay. Then we have here the you can also use this. Okay. So this dot name equals to name. So either of the two, super or this, you could use either of the two. So this age, that age. So instead of using super, I'm going to use this instead. Okay. Of course, super will work too. Okay. I'm going to use this instead for consistency. Okay. Since we use this also in here. Okay. Now, so now that we will be able now to create a new Scholar still have an error. Oh, because in here we indicated a fourth parameter. So for our allowance, so here, let's add allowance. Now these methods work. Okay, so go back on our derailed topic about method overriding. As we all know, say age from student class only print hi, my age is 25 or the value of the age. On the other hand, say age on our scholar class, we override the say age from before. Now prints hi, my age is and I am a scholar. So if we run this, we should expect two different outputs. Right. So the first one is the basic. Uh, sorry, the first one is the uh, basic output that we're expecting for a student method or for our student class. Okay. And then the second one is the output that we're expecting for our scholar class. Okay. So that is the concept of method overriding. All right. So for the last part, we're going to discuss interface. Okay. Interface combines the concept of abstraction, inheritance, and polymorphism. So what is an interface? So let us say an interface is a blueprint where a high-level blueprint where you indicate methods, of course, and attributes if you want to, uh, but it doesn't have anything inside it. Okay, so let us create an interface first. Create that, and instead of creating a class, we are going to create an interface. So let us say Scholar. So let's try that. Finish. Then we have created a Scholar interface. As you can see here, it's public interface. First of all, this is inheritance because you will inherit this interface to a class. Okay, so not exactly inheritance, but almost same concept. Okay. Another thing is this is abstraction. Okay, because we won't be able to see the code inside here. Let us add the method and interfaces here. Okay, I mean the methods here. So for example, I add public. Let us say a scholar should have requirements instead of documents. So submit requirements. So a scholar should submit requirements. Okay, so we could do that. So this is encapsulation because we're only indicating uh, the method that we're going to use, but we're not going to indicate what that method would be doing in an interface. Okay. So for that method to have a functions or to have a code inside, you need to implement this interface on where you're going to use this interface with. Okay. In our case, we're going to use it in Scholar class. Okay. This is also form of polymorphism because again, it's like we're going to override what these submit requirements do. For example, use the keyword implements, then we're going to implement Scholar interface. Now we implemented it. Now so Java is returning an error because there is a class from the Scholar interface that needs to be overridden. Okay, so to do that, just I'll enter here, then implements all abstract methods. Okay, so when I do that right here, we can see now that the class, the method indicated in here must be overridden in here. So that is polymorphism. Okay? Abstraction because it is very abstract. There's nothing inside the code. Okay? Inheritance because we inherit it from this code. Inherit this interface to Scholar class, to this class. Okay? So let us say I'm going to override it. S out, submitting like that, and then go back here. Okay? The scholars can now use that method from the interface by that submit requirements. Now it's present in here now. So when we run this, now CLI can submit requirements now. That's it. That's the basic concept of OOP. Hopefully, I've explained it clearly. All right. Thank you for listening. Okay. Take care.